Good morning, class. So today what we're going to do, and for the next couple of days, is we're going to review small bits of Chapter 10. Your test is 2 days. It starts on Wednesday and it finishes up on Thursday. I would recommend that you do my class first so that I can help you study for that test. And I would actually recommend that you take notes because you can use your handwritten notes on your test. So it's a good idea to have this handy and easy to find. So 10.1 and 10.2 were about understanding the properties of the square root function, understanding the properties of the cube root function, knowing how to translate those functions, and knowing how to calculate the average rate of change for those functions. So we're going to start with the square root function. These are some things you should know about the square root function. So say this function is the square root of x. One thing you should know is that you can't take the square root of a negative number. So the square root of x has a domain from 0 to infinity because you can't plug a negative number into this function. You can plug a 0 into the function, that's fine. Square root of 0 is just 0, but you can't plug a negative number in. The range for the square root function is from 0 to infinity. And then what square root means that you are trying to figure out what number multiplies to give you your input. So what number multiplies by itself twice to give you the input. So for example, if your input is 25, the square root of 25 would be 5. Your output would be 5. So if we graph this function, and you should be comfortable with knowing what the graph of this function looks like, it starts at the origin because 0 square root of 0 is 0. It passes through the point 1, 1 because the square root of 1 is 1. And then it passes through the point 4, 2 because the square root of 4 is 2. And it has the shape of kind of a sideways half of a parabola. It continues on forever in the to the right, so that's why our domain is out to infinity, and it also gradually increases to infinity for the y-coordinate, so that's why our range is out to infinity. By the way, later in this chapter we talk about end behavior, and the end behavior for the square root function is as x goes to infinity, the square root function goes to infinity, because the right end of this graph continues upward. The left end of this graph does not have an end behavior because our behavior just stops here at 0. So we don't have an end behavior for the other end of this graph. That's the first graph that you should be comfortable with. You should know what the square root function looks like. In 10.2 you learned about the cube root function. The meaning of the cube root function is what number multiplies times itself 3 times to give you your input. So if your input is, say, 27, your output would be 3 because 3 times 3 times 3 gives you 27. The other thing about the cube root function is that if your input is negative 27, your output would be negative 3, because it is true that negative 3 times negative 3 times negative 3 gives you negative 27. So you are allowed to use negative inputs for the cube root function. The cube root function passes through the origin just like the square root function is, but the domain and range are different. So the domain for the cube root function is from negative infinity to infinity. The range for the cube root function is from negative infinity to infinity. And the cube root function has 2 end behaviors, but let's graph it first. So if I graph the cube root function, it passes through 0, 0. It passes through 1, 1, It also passes through negative 1, 1. The next point that's on the graph out here would be 8, or the next integer value would be 8, 2. This graph does not increase very fast, but it does increase. And so it looks something like this. Something like that. I described that as kind of curvy lightning. It has two ends, so if I look at the end behavior to the right, as x goes to infinity, this function also goes slowly, but up to infinity as well. And as x goes to negative infinity, so if I look at this end, that arrow is pointing down, so that function goes to negative infinity. If you want to translate these functions, attaching the translation to the x-coordinate will move it right or left. Adding it onto the end will move it up or down. So an example of a translated square root function would be like g of x is equal to the square root of x plus 1 minus 2. That's an example of one. Anything inside of the square root is going to be a right or left translation, and the sign will be opposite. So when it's attached to the x, the sign is the opposite of what we think. Positive 1 is to the right, but if I add 1 to my x-coordinate, that actually shifts my graph left. So this would be a left 1 translation. And then numbers that are added onto the output, or the end of the function, are going to be up or down translations, and those ones don't change sign. So this would be down 2 units. The point that I recommend you move so that you know what this looks like is I recommend that you move the origin. So if I start at 0, 0 on F, if I go to G, I would start left 1, down 2 from 0, 0. So G starts here and then has the exact same shape as F. So this is a graph of G, and this is a graph of F. All right. If I want to translate the cube root function, I would translate that cube root function the same kind of principle. Anything inside the radical sign is going to be a right or left translation, let's say minus 1 here. And anything outside of the radical is going to be an up or down translation. So the graph of G, the point that I recommend you move again is this 0, 0 point. Instead of 0, 0, we're going to go right 1, up 2. So our point where our graph bends is going to be at 1, 2. And it's going to have that same shape, slowly increasing to infinity and slowly decreasing to negative infinity. So that's how translations work with the square root and the cube root function. Your job on this test will be to understand A, which graph is a square root, which graph is a cube root, and B, how to translate those graphs. The next video is going to go over average rate of change for these functions, so I'll stop here so that it's not too long for you.